So let's look at ideal gas law problem number 3. It says that at negative 45 Celsius degrees, we have 71 grams of fluorine gas, and that takes up 6,843 milliliter of space. And we want to figure out the pressure of that gas in kilopascal. So first we need to find which R, that's the constant we need to use, and since the answer needs to be in kilopascal, we need to find the R that has kilopascal, and that is 8.314 kilopascal times liter divided by mole times Kelvin. We also then need to turn our Celsius into Kelvin and our milliliters into liter, since we need to have the same units throughout this problem before we can solve it. That also solves a problem since 45 degrees Celsius is negative, and dealing with negative is gives a little bit of a headache, so it's a good thing that we need to turn that into Kelvin. And turning those milliliters into liters. We now have all the information that we gotten turned into the correct units, except 71 grams. In the ideal gas law, we deal with moles. We need to turn it into mole. So to figure out how many moles that is, we need to find the molar mass, and that is directly correlated to the weight of the atom. And so we go into the periodic table and find out that one little atom of fluorine weighs roughly 9, and then one molecule would then be 18 grams per mole. So that's 1 mole of that gas is then 18 grams. And so we can just put that into a little equation and then figure out how many moles that would be if we have 71 grams. And we're going to find out that 71 grams equals roughly 3.7 mole. And I need to put one line under that answer, since this is not the final answer. This is just a partial answer. Then we can use all the information that we have to put it into the ideal gas law, which is pressure times volume equals mole times R, which is the constant, times temperature. We need to solve that on pressure, so I can find what P is by dividing on volume on both sides. So I'm going to end up with P equal nRT divided by volume. So I can just put in all the information I have, and remember to always carry with you your units. That's how you double check that you're doing the math correct, because you're going to end up with only one unit here, and that is kilopascal. So as I put in the information, you're going to see here that I have mole both over and under the division line, Kelvin both over and under the division line, liter over and under the division line, but what stands alone is the kilopascal, which is a little hint here that we are on the right path. So we can cross out liter against liter if it's both over and under the division line. Same thing with mole. Can cross that out since we have one over and one under the division line. And the same thing with Kelvin. If it's both over and under the division line, we can just cross that out. And so we end up with only kilopascal, which is what we want to have our answer in. So we know we're on the right path here. Then we can just multiply and divide to find out our answer. And we're going to find out that that is 1025 kilopascal. And I need to put 2 lines, a double line under that answer, because this is the final answer.